Welcome to Chapter 5, Extension number 2, where we're going to talk about polynomials that look like this: x squared plus bx plus c. Okay? I'd like to first look at Algebra Tiles. I don't know if you remember doing these in Math 9, but Algebra Tiles, I know there's yellow and red on the screen, but I like to use white and black or dark for the negatives, so that if you're using pencil, you can easily show the difference. Okay. Now, I don't know if you remember, but if I did something like this, 3 times 2, I could do that as an array or an area model. I can say that there are 3 rows of 2 groups. Okay. So similarly, when I actually use something like x plus 3 times x plus 2, that's like the 3 and the 2. So I can say that x plus 3 would be, the factor here, which would be an x, that would be a rod, right? And then 3, so that's a 1, and a 1. And then multiplying that by x plus 2, so there's another x here, and then a 1 and a 1 for 2. And if I were to use this area model, then look at what I would get as a result. Well, an x times an x gives us the big x squared. And then x times 1 just gives us x, another x, and another x. And over here you'll notice there's another x, and another x. And what's left over in this little corner? 6 little squares, and there you have it. So ultimately, what happened here? Well, you produced an x squared term, then you produced 3 x's, then you produced 2 x's, and then you had the 6 little ones. And that actually simplifies to x squared plus 5x plus 6. And that's the actual answer to our question, x plus 3 times x plus 2. Okay? Now I'm going to ask you to see if you do the same thing now with the next question, x plus 1 times x minus 2. Try it on your own, and then double check your answer with me. And with the negatives, I will use dark. And so if we do this, x times x, that gives us, x squared. Okay. The x times 1 gives us a positive x. A negative 1 times x gives us a negative x. A negative 1 times x gives us another negative x, so that's actually negative 2x. And then a negative 1 times positive 1, of course, is negative 1, so a negative 1 small square, and also that, so that's minus 2. And if you simplify, that's x squared minus x minus 2. So can you actually describe a strategy now that you could use to multiply 2 binomials? 2 binomials, once again, are those things with 2 terms, so binomial 2 terms, without sketching the rectangle? If you think about what you did, you might be thinking, oh, I did this. X times x give you x squared. You're right. And then you did this. X times negative 2 to give you negative 2x. Yeah, you did. And then 1 times x to give you the middle term, of x. And then 1 times negative 2. So there's many ways to describe this. Some people like to use the acronym FOIL, because that stands for the first terms multiplied together, then the outer terms multiplied together, then the inner terms multiplied together, and then finally the last term multiplied together. Or some people like to use the idea of the distributive property. This is where we're taking all the terms in the first bracket and distributing it to all the terms in the second bracket. Okay? So, whatever strategy you use, doesn't matter to me, but what I like to do is practice doing the expansion of these binomials. Okay? So go ahead, try it. I like this, x times x, that's x squared, x times 5, 5x. Negative 6 times x, negative 6x, and negative 6 times 5, negative 30. Then just simplify by combining those middle terms together, and there you have it. Done. Okay. Doesn't matter if it's an x in front or a number in front, same strategy, right? So let's try. 12 times 3. Yep, 36. 12 times y. 12y. Negative y times 3. Minus 3y. Negative y times y. Minus y squared. Simplifying once again. Now, some math people like having the terms written in what we call descending order, with the highest power first. And if that's the case, I would just rearrange the terms, and this would be the final answer. Okay? I'm going to ask you to try C and D on your own. Okay? Go. Negative a squared plus 2a minus 1. Good. Now the last one, tricky. Please do not say, oh, I'm just going to distribute the square, x squared plus 9. Hold on. First of all, that's not right. And second of all, let me show you why. If I were to use algebra tiles, look, it's x and then a 3. 1, 2, 3. X and a 1, 2, 3. Notice you have an x squared term, and then yes, you have your 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. But what you seem to have forgotten is that there's stuff up here and there. So that's not good. So either you draw the picture and say, oh, I'm missing 1, 2, 3, 4, 5, 6 x's, or another strategy could be just to rewrite this as x plus 3 times x plus 3. When students do this, they know, yes, I need to FOIL or use the distributive property. And when they do that, it seems like they always do it right. But when you just leave like this and try to make a shortcut, they seem to always do it wrong. So the final answer here is actually x squared plus 6x plus 9. Okay, done. Okay, that's what we call expanding. We get rid of the brackets, we expand. And the next thing I want to show you is this. There's another process called factoring. And expanding and factoring are inverse processes. Inverse meaning you do one and then do the other one, you get back the same thing. So one is just the opposite of the other. So if I can use algebra tiles, let's hope we can use that to help us understand this idea of factoring. So for our first question here, x squared plus 7x plus 10, I have listed the algebra tiles. And your goal is to try to rearrange the tiles to represent the terms into the rectangle. So your goal is to create a rectangle. So remember our algebra tiles, we have like our axes here. We always like to put the x squared term in the top left corner. There's one of them, so I'll do that. And then now here's the challenge. How can I rearrange these 7 x's? I can put them over here like this, or down here like this, or a combination of both, so that I can rearrange that. And then also, in the end, I have these 10 ones that go into this right corner here. Okay. So this is where if you actually have them at home, you can actually move them around. And if you don't, you just have to keep drawing. Yeah, it's kind of guessing and testing here. You could perhaps try 1 here, right? 1, and then another one here. 2, 3, 4, 5, 6, and maybe 7. If you do that, look how many pieces you need here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We don't have 12 pieces, we only have 10. Problem. So how can we keep doing this to make this only 10? Maybe I should, yeah, take that one and move it over here. Let's see what happens now. There's still 7 of them, right? 5 and 2. And then now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. This is the correct drawing. But then what does this mean? Well, what is the factors? You're looking here. This is x, and then you have 1, 2, 3, 4, 5. And over here you have x, and you have 1, 2. So your factors are x plus 5, and x plus 2. So ultimately what you just told me is that x squared plus 7x plus 10 can be factored into x plus 2 times x plus 5. Okay. See if now you can try the next one. Okay. See if you can factor this polynomial. Remember, x squared is always in the left-hand corner. This time I have 3 negative x's. Okay, so maybe one negative x here, another negative x here. I guess I'll put one up here. And then, oh, look at that. Oh yes, oh yes. I think this works. Why? Because this is an x. These are negative ones. Right? Here's another x. And this is also negative 1. So notice a negative 1 times a negative 1 gives you a positive 1. That works. And so this lovely picture represents this statement. X squared minus 3x plus 2 is now equivalent to x minus 2. That's the top. And then also x, oops, not plus 1, x minus 1. That's what's on the left. Okay. All right. Last one. Try, try, and try. Same thing at the first part. This time I have negative 4x. Okay, so negative 1, maybe negative 2, negative 3, negative 4. And that means I have, 4 positive. Okay, that didn't work. Let's try something else then. Sure, 1 there, 1, 2, 3. Positive 1, 2, 3. That didn't work either. Notice that these are negative. That's odd, because how in the world am I supposed to get a negative if I'm doing a negative times a negative? That's always going to be a positive. I think I'm in trouble here. The only way to get negatives for these small little ones, right, is if you have a negative rod times a positive rod. I don't have any positive rods here, do I? Perhaps I need to add one in. But if you add one in, that changes the whole equation. Not unless if you add one positive in and also one negative in. We call this here what they call a zero pair. The pair together actually equals to 0. Now let's see if that will actually help us with this question. So let's go back to drawing again. X squared. 4 negatives, so maybe one there, another one there, another one there, another one there. 4 negatives. Oh wait, we don't have 4 negatives now. We actually have 5 negatives. Right, that extra negative. And then maybe the 1 positive. Now look, a positive times a negative gives us a negative. Negative 1. Negative 1. Negative 1. Negative 1. Negative 1. It worked. All because we had to add in this 0 pair. But it worked. So our final answer up top here would be x. Negative 1, negative 2, negative 3, negative 4, negative 5. X minus 5. This over here, x. And then a positive 1. X plus 1. So, ultimately, x squared minus 4x minus 5 is equivalent to x minus 5 times x plus 1. Nice. Now I want you to look back at these 3 examples, and I want you to connect these ideas. Okay, this b value with these numbers, and also this c value with these numbers. Okay, same thing here. B value with these numbers, c value with these numbers. So for polynomials of this form, wherever it says x squared times bx, so a number in front of the x, and then plus c, what are we doing here? You're actually doing this. You're looking for two factors that what to see. -5, -5 and 1, 2, -2, -1. Yeah, if you said that it's two factors that multiply to c, I'm very happy. And if you're looking at the same two factors, what must you do to get b? If you said add, you are correct. And so this gives rise to what we need to do in learning how to factor a trinomial. So if you want to factor the trinomial, you just need to look for two factors that multiply to the constant c. And those same two factors add to the coefficient in front of the x. And that's how we go about factoring. And if you want me to prove this to you, I can. I'm just going to quickly expand this. Let's just call m and n our numbers. So if I were to expand, x times x is x squared. X times n would be nx, m times x would be mx, and then m times n would be mn. Now notice those two middle terms here both have an x, so I can factor that out, and I'm left with n plus m in a bracket. And notice that if I were to compare this now, compare this, I get x squared, or compared to this, x squared plus bx plus c. Yes, this equals to c, and this equals to n plus n. So notice the b value, two of the numbers have to be added together. The c value, two numbers have to be multiplied together. Okay? So ultimately now let's try example number 2, where I'm asking you to go backwards now and factor. I'm going to ask you to check your answers by either drawing algebra tiles or expanding, but I won't, so that this video doesn't go super long. But the idea here is think about this. Find two numbers that multiply to 30, and those same two numbers add to 11. Think. 5 times 6, 5 plus 6, x plus 5 times x plus 6. Done! That's it. You're done. So this one here, find two numbers that multiply to -24. Those same two numbers add to -2. So once again, you need to know your multiplication table pretty well. You were probably saying 6 and 4. Remember, this is -24, so one of these numbers has to be negative. And that's how you look at the negative, the -2 statement here. Which one is negative? Is it the 4 or the 6? Well, it has to be the 6. So -6 plus 4 is -2. Therefore, my answer is x minus 6 times x plus 4. Done. Okay. By the way, the order of these terms doesn't matter. You could write this as x plus 4 times x minus 6. That's the same thing. Okay? I'm going to let you try 35. Once again, I'm a math person that likes to follow those math rules where the highest degree is the first term. I just think it's easy to do. So I'm going to ask you now to go ahead and try this on your own. Okay? Find two numbers that multiply to 35, and those same two numbers add to -12. I hope you said 5 times 7, but really it's not 5 times 7, but -5 times -7. So the factors are x minus 5, x minus 7. Done. Okay. How about the ones underneath? They look a little bit scarier, but that's okay. No big deal if it's a y squared here like this, because it's the same process where I'm going to ask you to find two numbers that multiply to 12, and the same numbers add to -8. And I heard many of you say 2 and 6, 2 and 6, close, negative. So this now becomes x minus 2, but remember it's 12y squared, so we just have to tack on a y at the end. And then x minus 6, y at the end, because a y times a y will give you that y squared term. And notice that if I were to take the x times the y, I'll get xy, which is the middle. So this looks good. Okay. Now for part E and F, I want to warn you that it might be advisable to factor out the greatest common factor first. Okay, so I look for numbers E here and I see, look, 7, 42, and 63. I think all terms can be divisible by 7, and so 63 divided by 7 is 9. Here we go. Look at that. And now we have a trinomial of the form x squared plus bx plus c. So now I'll just ask you to find two numbers that multiply to 9, and those same two numbers add to -6. And many of you already said this to me earlier. Yay! It's x minus 3 times x minus 3. And really, x minus 3 times x minus 3 can also be written as x minus 3 all squared. Either or will be good in my books. Okay. So I'll let you try now this one yourself. Taking out -3y perhaps. Now you're left with x to the power of 4 minus 4x squared. And then 96 divided by 3, I think that's 32. So think about this as, two numbers that multiply to 32 add to -4. 8 and 4. Okay. One of them has to be negative though, right? To get -4? Oh, I guess not. Maybe that's not the right combination. Okay, what else can we do? 16 and 2 perhaps? No. I don't think this is possible. Not possible. So if it's not possible, guess what? We just have to leave it like this, and we're done. Okay? Not everything can be factored. Not everything is possible when you find two numbers multiplying something, and those same two numbers adding something else. So just be aware of that. Alright. Example number 3. And then some challenge stuff that maybe I'll leave for those who really want to do it. But if you don't, it's okay. For what values of k can each trinomial be factored? Now I'm saying, hey, can you tell me what the values of k could be for this? Well, I'll do the first one, then you can do the next one. This one, if you think about it, we're still doing that process. Find two numbers that multiply to 8. Those same two numbers now have to add to k. So if you can list out all the combinations that multiply to 8, that'll help me out. Yeah, 1 and 8. 2 and 4. Is that it? Don't forget, -1, -8, and also -2 and -4. So these are the combinations, and now I ask you to add them together. Well, what's 1 plus 8? Yeah, that's 9. What's 2 plus 4? That's 6. What's -1 plus -8? Yeah, -9. And then how about this? -6. So really, what is the values of k? It's either 9, 6, -9, or -6. And that is what we can have. So only these particular values of k allow us to actually factor this trinomial into two binomials. Alright, you try B. Two numbers that multiply to -18. The same combination then equals my k. Here we go, 1 and -18. And don't forget -1 and +18. 2 and -9. -2 and +9. 3 and -6. -3 and +6. And that's it. Adding things together, I guess I get -17, I get +17. I get -7, I get +7. I get -3, I get +3. So k must be +17, +7, or +3. Those are the only 6 combinations that will allow you to factor this trinomial x squared plus kx minus 18. Okay? All right. So, some challenge questions. You want to do this? Great. Keep listening. If you don't, I guess you're done. What's so challenging about number A? Well, I think the first thing we can do is factor out the 2. And the only challenging part here is that it's usually a squared, but now it's a to the power 4, but that's okay because the middle term is a squared. So ultimately the same process works. Right? Find two numbers, multiply 18, add to 9. Those numbers are 6 and 3. But this time, instead of having a plus 6 and a plus 3, because in our other questions it was always a squared, this is a to the power 4, so what do we need to do if we want to split that up? Yeah, it has to actually be a squared, right? A squared times a squared gives you a to the power 4. And then now a squared times 3, and then 6 times a squared, and that gives you the 9a squared. And then the 6 times 3 gives you 18. So this was a to the power 4, it becomes a squared, a squared. By the way, if it was a to the power 6, you would split that up into a cubed and a cubed. Okay? Now, for part B, you're like, ooh, scary exponents, but you know what? Same idea. Okay? Maybe it would help if I asked you to do this. Remember how I can change the exponents? I can rewrite it like this. Right? 2n. I can write it as n2 as well. And if I put brackets around here, then maybe this will also help you out, because look. This is kind of like the same as before. Maybe to make it even nicer, I'll make a substitution, and then it'll look like something you're more familiar with. Yeah, look at that. Look at that. Look at that. It's the same form. So go ahead now. Find two numbers that multiply to 12, and those same two numbers add to negative 8. 6 and 2, good. So this becomes a minus 6, a minus 2. But wait, that's not how we started the question. We started it with this, right? A equals to x to the power n, so we need to re-substitute that back in. X to the power n minus 6, and x to the power n minus 2. And that is our final answer. Okay. Alright, C is similar. And I'm going to get you started, and then after that I want you to try to finish it. This is y, and remember 12m, 6m, I can write this as y to the 6m squared minus 7y to the 6m plus 10. Okay? Now it looks like part B, so I want you to try it, and then come back and check the answer with me. Okay? Press pause, please. Try it, then come back. Did you get this? Did you factor and get a minus 5 and then also a minus 2? And if that's the case, did you then re-substitute this back in? Y to the 6m minus 5 times y to the 6m minus 2? If so, ta-da! You win. Okay. And then D, E, and F are very similar, except now you have to do some greatest common factor first, I think. And then we can go ahead and solve. Let me try D and E, and then I'll let you try F, okay? D, I see that there's a factor of x and also m plus n in each of these three terms. When you take it out, you're left with x squared minus 8x plus 15. And now that's something similar to what we factored before. Two numbers multiply to 15. Same two numbers add to negative 8. Dum 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 dum, your brain is churning, and you get, yeah, x minus 5, x minus 3. So your final answer here is really x times m plus n times x minus 5 times x minus 3. That's it. E. Do you see the thing in the bracket? Yeah, that's like parts B and C. Maybe I'll make a substitution. This then becomes a squared plus 8a plus 15. I know how to factor this. Two numbers that multiply to 15 and add to 8. Yeah, that's just going to be a plus 5 times a plus 3. And then we resubstitute, so we get x squared plus 4x plus 5. And then we get x squared plus 4x plus 3. Done. Or are we? Because you should see that now we actually have two trinomials here. Can these be factored? Can you think of two numbers that multiply to 5 and add to positive 4? I can't. So I guess we're okay there. How about over here? Can you find two numbers that multiply to 3 and add to 4? I can. We're not okay here. You can factor this further. So this whole thing actually becomes x plus 3 times x plus 1. Wow. Doubly hard. So much factoring. Wow. And that is your final answer. Okay. And then sometimes you might get questions like F. I remember this one because I had that on my test when I was in Math Honors way back. So I thought I'd share my wealth with you. This one stumped me for over 30 minutes on a test, but I'm going to show you how F is actually very similar to E. So that's my hint to you. F is very similar to E. Can you see what you need to do to make F similar to E? Especially these middle terms here. Can you see what you can factor out from those middle terms? Perhaps you can, and you will not be like me, making a fatal mistake of doing this question for over 40 minutes on my test. And if you can factor and see that this is x plus 2y, you are brilliant. Or at least you're better than me. Now, why is this helpful then? Once again, I can make my substitution. Let a equals to x plus 2y. And you're left with a squared minus 12a minus 160. Once again, let's see if your multiplication skills will help you. Two numbers multiplying to negative 160 and adding to 12. 20 and 8. Good. Which one's negative? Negative 20. Good. So a minus 20 times a plus 8. And don't forget to resubstitute everything back in. So x plus 2y minus 20 times x plus 2y plus 8. There you have it. Some really challenging factoring questions. But please work on this unit and this stuff here. This is a skill that you need definitely in grade 11, 12, and even beyond. So make sure you know how to factor well.